So what does the Bohr model have to do with spectroscopy? Spectroscopy is the study of light. We can gather information through light. We can look at things. We can look at meteors, we can look at asteroids, we can look at stars and planets, and we can find out things about them through the study of the light that they give off. We call this spectroscopy. And here's how it works. If we look at this atom that we have here, this is just a made-up simulation, so I don't know what atom this would be. I think that the emission spectrum looks a little bit like Mercury's, so we'll just say that it's Mercury. Then the gaps between the rings here would look like this. And if it were a different Mercury atom, it would still look like this and would still give off this emission spectrum, because the gaps here equal the color bands that you would see over here. However, if we change to a different atom, one with the rings different spacing apart, like that, and we switch back and forth, you kind of see how a different atom, the ring shape might change. And therefore the gaps between the rings are different, and so they're different sizes, and so the colors required to jump up and down and back and forth are different, and so you would end up with an emission spectrum like this one, which actually only gives off UV, compared to this one we had a second ago that would give off like a blue, indigo, green, and a yellow. And so if you looked at something and you saw this spectrum, you would know that it was made from this kind of atom, whatever that might be. And if it looked like this, you would know it was made from this kind of atom. If the spectrum looked like this, if it were only giving off like red and infrared, you might connect it to this atom. And so you can identify atoms. You can actually also identify molecules. It also works that way. And so we can look at distant stars and determine what they're made of. We can look at planets. We've never been to Neptune, but we have a pretty good idea of what it's made out of because of the spectrum that we can observe. We point a telescope at it, we gather some light, put that light through a spectrograph machine, and we see what wavelengths are coming out. And those wavelengths serve as a description of what the gaps in these rings are, whether it looks like this or this or this, and that's how we can tell what kind of atom or the molecule that light's coming through or coming from, and so we can determine what kinds of elements or molecules are on that planet or star or moon. And so we know a great deal about what the universe is made of, places that we could never imagine going because it would take millions of years to get there through spectroscopy.